back to my channel. Today I'll give you a brief explanation about dimensions. The nature of physical quantity is expressed by dimensions. I repeat, the nature of a physical quantity is expressed by dimensions. The exact definition we could say for dimensions is this one. The dimensions of a physical quantity are the powers to which the base quantities are raised to represent that quantity. Dimensions are usually expressed in terms of square brackets like this. And in these brackets we write the dimensions. I hope so you all understood this definition and the main point. Before learning about dimensions, there are two tables which are very important. This is the first table, which is physical fundamental quantity, its SI unit and the symbol of SI unit. Mass, whose SI unit is kilogram and represented by symbol kg. In the same way, length, meter and denoted by small m. Time, second and s. Temperature, which is SI unit is Kelvin and represented by capital K. Amount of a substance, mole. I think so you have heard this name in the chemistry. Yeah. Next, current, ampere, A. Luminous intensity, candela, CD. The most important points here are kg, mass, second, Kelvin and ampere. You have to remember these terms very carefully. And guys, this is the second table, which is fundamental quantity and the dimensional form. For mass it's m, length L, time T, electric current is I, thermodynamic temperature is theta, amount of a substance mole, luminous intensity CD. Remember that these all formulas are kept in a square brackets. We have to use this very carefully and it is so important. Now let's go to dimension analysis. The first point you have to remember in dimension analysis about mass, length and time. Mass, the dimensional formula is m, for length is L and time is T. Remember. So now we'll discuss how to derive a dimension from a formula. Let's start. First, we'll discuss about velocity. I think you all know about what is the formula of velocity. It is displacement by time, isn't it? Displacement is measured in length, so we can write L, and time is measured in T, which is T. So what did we get? We got L, and if T goes to the numerator, it will become T power minus 1. This is the dimensional formula of velocity. We have to mention in the form of dimensional formula. So we have to write it as m power 0, L power 1 and T power minus 1. This is the dimensional formula. Now our second problem is about momentum. You all do know the formula of momentum, which is mv. M is mass and v is velocity. Mass is represented by m and velocity, we do know that it's displacement by time. Just now we have discussed that we can write this m, displacement which is measured in length, so we can write it as L, and time we have to write it as T. So the m is in the numerator, we can write m power 0 into L power 1, and when this T goes to the numerator, it becomes T power minus 1. This is the dimensional formula of momentum. About acceleration. We all do know the formula of acceleration, which is delta V by delta T. V is velocity and T is time. V, which is velocity, we can write it as displacement by time. And in the denominator, it's delta T by whole time. So, displacement and time, it's L by T by whole T. This gives rise to L T power minus 2. So we can write this as m power 0 L power 1 and T power minus 2. This is the dimensional formula of acceleration. Now let's go through force. Force formula is mass into acceleration. So we all know that mass, which is m, and acceleration which is m power 0, L power 1 and T power minus 2. So mass into acceleration, which means m power 1 into m power 0 into L power 1 into T power minus 2, which is m power 1, L power 1 and T power minus 2. This is the dimensional formula of force. Remember this, it is very important. Force, by dimension of force, we can calculate many other dimensional formulas. Now let's know about pressure. The formula of pressure is force by area. Just now we have derived the dimensional formula of force, which is mL T power minus 1 by area. Area is length into length. We can directly write it as L square. So the dimensional formula of pressure will be m, L power 2 it will go numerator and it will get simplified to L power minus 1 and T power minus 2. We got the dimensional formula of pressure. Let's know about now work. The formula of work is force into displacement. We have derived the dimensional form of force, and I said it's very important, which is mL T power minus 2, and displacement we calculate in the form of length, so we can write it as into L. So it will be m L square and T power minus 2. This is the dimensional formula for the work. G is also having the same SI unit as work. So it is joules. So it would have the same dimensional formula of work. Not only energy, but kinetic energy, potential energy and nuclear energy, etc. would have the same dimensional formula, which is m power 1, L power 2 and T power minus 2, because they have the same SI unit. Now let's go through about moment of inertia, which is represented by symbol I. I repeat, I means moment of inertia, which is mass into distance square. Mass is represented by m and distance is represented by L, which is L square. So we can write it as m power 1, L square and T power 0. This is the dimensional formula of moment of inertia. Now let's know about surface tension, whose dimensional formula or normal formula is F by L. We know that F has dimensional formula m L T power minus 2, and L we can write it as L. Here L and L get cancelled and the dimensional formula will be m power 1, L power 0, T power minus 2. This is the dimensional formula of surface tension. Now torque. The formula of torque is force into perpendicular distance. I repeat, this symbol is perpendicular distance. I said already that force dimensional formula is very important and we use it for many others. So force is m L T power minus 2. Distance, perpendicular distance or distance, both are used by symbol L. So the dimensional formula of torque will be m L square T power minus 2. Now let's get to know about stress. The formula of stress is force by area. The dimensional formula of force is m L T power minus 2, and for area it is length into breadth for rectangle, and length into length or side into side for square. So we can write L square because it's measured as length. Now the dimensional formula of this will be m L power minus 1 and T power minus 2 of stress. Strain. We'll know about strain. What is the formula of strain? It's delta L by L, which is, we can represent it by L by L, which gets cancelled and there will be nothing, dash. Why? Because strain is a dimensionless formula which doesn't have any dimension. There are many other dimensionless formulas. I'll give you a few examples. Now let's know about one more dimensionless quantity, which is refractive index. What is the formula of this refractive index? It's V1 by V2. V is velocity. Velocity, normally we know the formula, it's displacement by time. It will get cancelled, displacement by time by displacement by time. So the final answer will be L power 0, m power 0 and T power 0. So this is also dimensionless quantity. Now let's get to know about mechanical advantage. The term is mechanical advantage. For this we can write it as m L T power minus 2 by m L T power minus 2. They have same quantities, numerator, denominator, they get cancelled, and what will be left? M power 0, L power 0, T power 0, T power 0. So this is the dimension. So what can be concluded? That mechanical advantage is also dimensionless quantity. Now we will know about potential difference. What is the formula of potential difference? It is work done by unit charge. What's it? Work done by unit charge. Which now we'll understand some basic thing, which is ampere. We do all know that ampere, it is A, temperature it's theta, and for current or charge we use Q as its dimensional formula. So which is, we can write work done by unit charge as W by Q. You're getting me right? This one is force into displacement by I into T. We have already discussed what is I. So what is the dimensional formula of force? Which is m L T power minus 2, displacement L, and I, which is current, so ampere, A, into T. So the simplification of this will be m power 1, L into L is L square. If this T goes to numerator, it will become T power minus 3, and A goes to numerator, it will become A power minus 1. This is the dimensional formula of potential difference. Now let's know about Boltzmann's constant. What's the term? It's Boltzmann constant. And the letter which we can use for this is K. There is a formula which we have to remember, which is PV is equals to KT. P is pressure, V is volume, K is Boltzmann constant, and T is temperature. From this formula, we can take out this K value in this way. K is equals to PV by T. Remember these two formulas. So now, by this formula, we can find the dimensional formula of Boltzmann constant. Here, P, pressure. What is the formula of pressure? We have discussed already, which is force by area. And what is the dimensional formula for volume? We can write it as area into length, and by temperature, which is theta. Force by area, this area gets cancelled. What is the dimensional formula of force? M L T power minus 2 into L by theta. L into L is L square. So M L square T power minus 2, and this theta will go to up and it will become theta power minus 1. This is the dimensional formula of Boltzmann constant. Now let's know about Planck's constant. Planck's constant, which we can write it as small h. So Planck's constant, the main formula is E is equals to hf. We have to know a formula which is E is equals to hf. E is equals to hf. We need the value of h. So if we take out h towards the other side, h is equals to f by E. Actually, here we have Planck's constant, which is represented by small h, which this is the formula. Energy, h is Planck's constant, and here f is frequency. So h is equals to energy by frequency. We know the dimensional formula of energy, which is equals to force and work, which is mL T power minus 2, and for frequency it's 1 by T. So it will be L into T, which is mL square T power minus 1. This is the dimensional formula of Planck's constant. Now we'll know about gravitational constant, which is G. We need to remember a formula which F is equals to G m1 m2 by distance square, which gives rise to another formula which is G is equals to F d square. D is distance, F is force, by mass 1 into mass 2. So G is equals to, we do know the dimensional formula of force, which is mL T power minus 2, and for distance it's L, so L square, and for mass it's m into m. This m and this m will get cancelled. So the dimensional formula will be m power 1 L cube and T power minus 2. This is the dimensional formula. I repeat, the dimensional formula of gravitational constant is m power minus 1 L cube and T power minus 2. This is the formula. Now let's know about angular velocity. We can represent this angular velocity by symbol omega. So we can write the formula as omega, or angular velocity. Angular velocity is equals to v by t. Here velocity is v is velocity, v by r, and sorry, v by r. V is velocity and r is radius. Velocity is displacement by time. Radius is measured in the form of length by length. So displacement by length is also L by T by L, which is L by T into L. So this gets cancelled. M power 0, L power 0, T power minus 1, which is the dimensional formula of angular velocity.